Good morning, everyone. So, welcome to the course of Ordinary Differential Equations. I am Krishnendra, Associate Professor at Department of Mathematics, BITS Pilani. So, in this course, we will see different methods to solve ordinary differential equation and mainly of first order and second order. In particular, the course is focused on second order ordinary differential equations. So the book which I am going to follow is Differential Equations with Applications and its Historical Notes by George F. Simmons. The topics which we are going to cover throughout this course is we start with first order differential equations, then second order differential equations, series solutions of second order differential equations. Then we'll see and study the properties of the solutions of Legendre equation and Bessel equation, the Laplace transform and how they can be used to solve the differential equations, Fourier coefficients and then system of equations, and then in the end we'll study the eigenvalues and eigenfunctions of a differential equation, and in the last we will study the qualitative behavior of the solutions of the differential equations. To begin with, let's start what is a differential equation. How do we define a differential equation? So here are a few examples of the differential equation. In all these differential equations, you can see that there are mainly two kind of the variables. One is dependent variable and one is independent variable. So here u is a function of x and y. So u depends on x and y, and therefore u is an dependent variable, while x and y are independent variable. So it means that an equation which involves dependent variable, its derivative, dependent variable and its derivative with respect to one or more independent variables. So we call it a differential equation and it is denoted as dE. So we have already discussed dependent variable. When y is a function of x, then y is dependent and x is an independent variable. So here u is a dependent variable and both x and y are independent variables. Order and degree of a differential equation. Let us consider this example. So this is a second order differential equation whose degree is 3. So I can define as order is the order of highest order derivative. Highest order derivative is 2 and degree is the power of highest order derivative. So the power of highest order derivative, which is 3. So we are mainly interested in order because we are going to talk about first order and second order differential equations. The next one is ordinary differential equation, partial differential equation. Again, since we are focused on ordinary differential equation, so we can say that it is a differential equation with only one independent variable, while partial differential equation has two or more independent variables. So for example, dy by dx is equal to 1. So only one dependent, one independent. But when you write del u by del x plus del u by del y is equal to 0, it has, and that's why this del sign is there. Whenever there are more than one independent variable, then partial derivative would come into the picture. Linear and non-linear differential equations. So for example, consider the differential equation y is equal to x y dash plus y dash square, or you can write down y dash is equal to x square. These are non-linear differential equation because in this case y dash square is there and in the other case y is multiplied with y dash. So I can say that we are interested in linear differential equation. So in this case, dependent variable and its derivatives have degree 1. So y dash square is not allowed and are not multiplied together. Independent variable could have any degree. So for example, the linear differential equation is y double dash plus 3y dash plus 3y is equal to 2x square. This is a linear differential equation, while the above two are non-linear differential equation. So in this course, we would be focusing on ordinary linear differential equations. Now we can quickly go through the solutions of a differential equation. So any function of x, because here x is an independent variable, so any function of x satisfying the given equation is the solution of a differential equation. For example, y is equal to sine x is the solution of this differential equation, and this is known as particular solution. Similarly, y is equal to cos x is also the solution of this differential equation, which means the particular solutions are not unique. Even y is equal to 2 sin x is also the solution of this differential equation. But if we write down the solution in such a form that it covers all possible solutions, then it is known as the general solution. So c1 cos x plus c2 sin x, where c1 c2 are arbitrary constants, they can take any value, any real value, and in this case you can see that all possible solutions of this differential equation are covered. So this is the general solution. The last is initial value problem and boundary value problem. So you can see this one is initial value problem and this one is boundary value problem. So when it's the order is n, then n conditions are defined to compute the values of the constants. Now if all these n conditions are defined at a single point, then I say that it's the initial value problem. If they are defined at 2 points, then we call it the boundary value problem. Okay, so this is how we introduce the differential equations, and we understand that we are going to discuss only how to solve the ordinary linear differential equations. So we'll start with first order differential equations in the coming lectures, and then we'll discuss the second order differential equations. Thank you for watching the video.